Okay, so in this problem we are looking for the pH of a weak base. So in order to find pH, remember we need concentration of H+, but we are dealing with a base, however, not an acid, so it would be a slightly different process. We'll end up finding the OH- first, and then using that to find the H+ or the pH. The first thing we need to do, like all these problems, is write out the reaction that takes place. In this case we have ammonia, okay, aqueous. For a base, it's going to react with water, and that is going to, it's a weak base, so it'll be a reversible process between the ammonium ion, NH4+, and the hydroxide ion, OH-. Okay, so if we were to write the K for this, because it's a base, it's a Kb, and that is going to be equal to the concentration of NH4+ times the concentration of OH- all over the concentration of NH3. Okay, remember that since H2O is a pure liquid, it will just be 1. We then need to know what the Kb of this is, because we can only find one of the three between the K, the pH, and the initial concentration. And in this case, since we're given that the Kb of the solution, it's an ammonia solution, we looked that up in the book, and you find that the value is 1.8 times 10 to the negative fifth for the Kb. Okay, so first thing we're going to need to do here is to make a Rice chart. So we're going to set up our equation, NH3 plus water, reversibly going to NH4 plus and hydroxide OH-. My initial is 0.20 molar. The water we're not going to worry about because the concentration of water can't change. Initially we're going to have no ammonium, we'll say no OH-. Therefore, as this ionizes, we will lose X. We will gain X of the ammonium and the hydroxide. So at equilibrium, we have X, 0.20 minus X. So we plug that in for our Kb, and what we find is we have X squared over 0.2 minus X. Okay, you'll notice this is very much just like what we've been doing for the acid problems. 1.8 times 10 to the negative fifth rounds this out. Now, if we go ahead and solve this, one of the things to do again is we can use the approximation. So if we assume that this x is so small that it's not really going to affect the 0.2, we can go ahead and just assume it away. So in that case, what we're going to do is just take 0.2 times 1.8 times 10 to the negative fifth. That will give us 3.6 times 10 to the negative 6. We're going to take the square root of that. Okay, and we're going to end up with a value for x equal to 0.00190, I'll call it. It's 0.001897, so we'll round it to that. Molar. Now, if you notice, this right now is the value of x. X is the value of the hydroxide concentration. So we can't find the pH directly from this, but since we know the interrelationship between the pOH and the pH, we can do it that way. So at this point, we have a choice. This is equal to the concentration of OH-. We can either do 1 times 10 to the negative 14th equals concentration of H plus times concentration of OH-, solve for concentration of H plus, find the pH, or we can take the negative log of this, which is what I'm going to do, and find the pOH. So the pOH equals the negative log of 0.0019. I'm actually going to use the value that's in the calculator to get it more accurate, and what we get is a pOH of 2.72. Okay, remember we have two sig figs here, and therefore we have two places after the decimal. Since we know that pH plus pOH equals 14, we can simply say, okay, the pH therefore is equal to 14 minus the pOH, in this case 2.72. So what we're going to get is, had I rounded that, yep, pH is equal to 11.28. Okay, and you look at this and you say, does that make sense? And 11.28 is greater than 7. It's basic. We have a weak base. That is a pretty reasonable answer. So that's the way that you do this. Okay, one of the quick things to note, just going forward to think about, is that if we didn't know what the base was, let's say that we were given a KB and we just said of a weak base, or we were trying to solve it, for a generic weak base solution, you'd simply just write out like B, in this case it would be the NH3 plus water, goes to HB plus OH minus. You could also write it as B minus plus water. Okay, in this case it would become just HB plus OH minus. But if you weren't looking to make a Rice chart and you're not given that it's ammonia or something that you know, you can always use just B as a fill-in for that. Just make sure you have the plus water here because you're going to need to form the hydroxide from it. Okay.